when I grew up in Pensacola, Florida, and that's where I settled because my dad was in the Marine Corps and we moved all over the United States. But starting in the 6th grade, I really started thinking about, well, what do I want to do when I get to be an adult? And I started building models of space stations and models of airplanes. And so I was an aerospace kid. I really enjoyed living close to the Naval Air Station in Pensacola. And I was really inspired by my dad and others that I saw in the military flying aircraft. And that's what got the initial bug to go after something in engineering. So the opportunity I had in Pensacola at the time was a system science degree. I had 2 years in electronics and 2 years in computers. And it was between the time that we were going from tubes, vacuum tubes, to solid state. And I was going to school with people in the military that had been doing it for 20 years. And so they could teach the class. And I was always trying to get as much knowledge as I could out of the books, but as much knowledge out of them as well. So that's the kind of field I got into. It was an engineering career, our school, if you will, to get some of the basics going. And then the cooperative education program that the University of West Florida had really allowed me to go see what I wanted to do when I got out of school. And that's what started my internship or my co-oping experience with NASA. I'd come up to the Marshall Space Flight Center for 3 months at a time and go back to school for 3 months at a time. I was in the computation laboratory out at the Marshall Space Flight Center working in a simulation branch, and we were simulating what it would be like to drive on the moon. Behind me is the Lunar Roving Vehicle, and this was a 1.5 year long program from initial concept to delivery to the Kennedy Space Center. And it all had to come together in terms of the ability of the astronauts to see if they're going to be able to drive it on the moon, as well as practicing deploying it. Our simulator out at the Marshall Space Flight Center was a 6 degree of freedom, movable base simulator that when the astronauts got seated in their seats, very much like what you see behind me here, they were looking at a 3-foot diameter TV screen of the moon. And when you closed the door and brought the simulator up to its starting point, and they started driving around on the moon, they would feel every little rock that they ran over. They would give feedback to us that they'd like to have more control authority. And so we'd incorporate an Ackerman steering system where the front wheels would turn to the right, the back wheels would turn to the left, and they could do a 10-foot circle. And they wanted that kind of maneuverability. They wanted to go faster, but we had some limitations on the moon so that we didn't allow the rover to hit a rock and turn over. The speed was only initially set up to go about 8 miles an hour.
Oh, wow.
Well, that didn't keep them from going faster. So on Eugene Cernan's last flight, the last man to step foot off the moon, Eugene got it up on a hill and got it up to 11.2 miles an hour. And then my buddy John Young said he got it up to 12, which he really didn't. He just wanted to say he went faster than the other guys.
Competitive, aren't they?
They are indeed.
So as you started out, you were at the Lunar Rover project, and then you continued on with that project in other roles?
I did, but you know what was really cool about this, I got to help run the computers that ran the simulation. I got to make changes to the program to take into account this double Ackerman steering, for instance. But I used to go pick the astronauts up out at Redstone when they'd fly in from Houston in their T-38s. And I'd go get them as a 20-year-old college student, and drive them over to our simulation facility. And the conversation, front seat to back seat, I still remember today, where they would talk about if you hadn't cut me off at 10,000 feet, I would have landed first out here at Redstone. And it was all this competitiveness that I saw over that period of time. You know, I got to wear some of the spacesuits that they wore back in the day. So I was actually wearing Jim Lovell's training suit in this picture that you see on the day that we were actually deploying it during the Apollo 15 mission. And the suits are very cumbersome. Back in the day, I only weighed 145 pounds. But by the time I got my spacesuit on and my portable life support system, which I didn't really carry around, it was always pre-positioned for me, I weighed 350 pounds. But on the moon, they weighed 60 or 70 pounds. So it wasn't really an issue. But to be able to get in the suits and actually go through the driving of the lunar rover, and I was focused in on the steering system, which the first ones that we had was a straight up and down pistol grip. But after I drive it for about an hour, it'd bring blood to my wrist. So we brought some human factors engineers in and redesigned it into a T-handle And now with a ring that's in your glove, the left and right became real easy. Moving your hand forward and backwards solved all the issues that we had. It's the smallest room I've ever been in. So once you put that helmet on and you hear it click, that's where they were on the moon for 6 or 7 hours, closer to 8 hours on some of their EVAs that they had. But it was really a neat experience to get in something with 20 layers of material between you and the outside world, pressurized to about 5.5 psi, and go through all the procedures of deploying the Lunar Rover and driving the Lunar Rover to make sure they were going to have the capability that they needed to go to other mineral sites up on the moon. So this vehicle, like the one behind me here, on the moon went over 20 miles. They brought back over 200 pounds of rocks and really got to explore the moon with a lot greater ease than walking or pulling a cart behind them. So I think the challenges really came about from the short period of time that we had. We had a gentleman that worked for Boeing that actually went down to Montgomery Wards and came up with the poolside seats that you see behind us. Everything had a weight bogey on it, so we had to be under 480 pounds for the Lunar Rover. And it was to try to go make sure that we were living within the design constraints so that our payload, our rover, didn't exceed the weight that was allotted to us in order for us to be able to get to the moon. So those were the challenges, to meet all the requirements, to make sure we had enough redundancy in the vehicle so that if something failed, they could in fact make their way back to the limb. They stayed within about 5 miles of the home base, went over 20 miles on the moon, but never really did have any major issues with the rover. Well, those tires are made out of piano wire, and the temperature's plus or minus 250 degrees on the moon. The spacesuits, the rover, and the limb had that kind of temperature extremes. And it was really interesting to talk to the guys who went to the moon, facing the sun or turning away from the sun. You instantly felt the difference. Even though you had on long johns with 150 feet of little tubing from your shoulders down to your ankle that you could cool yourself off, and then the air conditioning and heating system inside the spacesuit. Back when I was a co-op student, I was thinking about trying to finish school and trying to find that first job. Times were different back in that time frame. The Vietnam War was still going on, and I wanted to have that college education before I tried to go on and explore anything else. So the Rover was kind of a neat program to go work on, but I knew that after I got hired by NASA, there was going to be another knock at the door. And we'll get into that here a little bit later, I think, in some of the questions you might have. But I went off and flew military airplanes, but came back to NASA. And we'll talk more about that in a little bit as well. I think, it was kind of fun watching the astronauts drive on the moon. So sitting in the seat and watching them drive around, we had a TV set, and you could see them up there doing the same thing they did in the simulator. They try to go as fast as they could go. They would fishtail, they would rooster tail, dust out the back. The memories were just great of watching the astronauts drive. They'd get driving along and all of a sudden come up on boulders, and they would stop and look off to the left and right. You can't turn around in that spacesuit very easily. And I don't remember if they had rear view mirrors. We gave them an ability to reverse, but they just take their Velcro seat belts off and jump out and pick up the Lunar Rover and turn it around and go back out the way they came in. Later they told me that wasn't rocket science, that was common sense. So they had a blast, actually taking this vehicle and looking back at their simulations, giving us the feedback that the simulations that we had at NASA, the Marshall Space Flight Center, really replicated what they were doing up on the moon. They really didn't have any big surprises out of the rover. It performed the way they were trained, and certainly the way the vehicle was supposed to perform. So it was just kind of fun to watch it. And then all these many years later, all this had kind of gone to the back of my memory until the 50th anniversary came around. And we started digging up photos and our own memories of what it was like back in the day, going to the moon. 6 months after watching Neil and Buzz step foot on the moon, I was working for NASA as a co-op student, and almost immediately got thrown right in the middle of the Lunar Roving Vehicle activities. And so looking back on it and looking at what we're trying to do when we go back to the moon or to go to Mars and bring up some of those capabilities that we had way back in the early 70s is cool. This is so neat that we reached out and then they reached back to us to go build a Lunar Rover 1G capability, something that we could use in parades and just showcase of what we did back in the late 60s and early 70s. They came at this, the team out at Polaris was just fantastic. The employees wanted to all be part of it. They managed to grab something from every product line that they make at Polaris. And they had a short period of time. They had a year to really go pull the design together and have this thing ready for the 50th anniversary. And it was just fun. It drove like the simulator. Of course, I'm looking back 50 years or 48 years ago at what we drove back in the day. But I can't help but think with the double accrement steering that they put on it, its maneuverability, it was just fantastic.
Brought you back those 48 years back to the original.
Well, and it did. And then I got to take my wife for a ride on the Lunar Rover. I never thought I'd get a chance to do that.
That's cool.
First of all, I wasn't married back when I was working on it as a young person. And then to share that experience with my family and friends, it was really cool. All brought to me courtesy of Polaris. So I got caught up in the Vietnam era. I managed to stay out of Southeast Asia. I got to go to flight school and fly that same T-38 that the astronauts that rode in my car would tell me stories about. I stayed within inside the envelope, whereas I think occasionally they flew outside the envelope of that jet's performance, but that was just the nature of who they were. So my primary airplane was a C-130. I got to go fly all over the world and haul the 82nd Airborne and the 101st to places I would have never gone otherwise, from the Panama Canal Zone to all over Europe, and really had a wonderful time doing that. As the war came to an end, I had the opportunity to come back to NASA. I still missed the flying, so I decided to go up to Nashville and fly in the Tennessee Air National Guard. Went from E models and H models back to A model C-130s, but they just flew the same. And so I did that for a total of about 7.5 years, active duty and my guard time. And then I had to decide what I wanted to be when I grew up. But all of that really lended itself to helping me with things like getting into the Skylab Reboost program and flying some simulators with Fred Hayes out in Denver. So that military experience brought me back here to the center with some piloting experiences to fly what I was hoping to be a shuttle simulator, which we'd already started before I left, a shuttle simulator that would actually allow the astronauts to practice takeoff and landings. Politics kind of entered into the scene, and all the training went to the Houston Center, the Johnson Space Flight Center. And so we started taking on other projects that kept me pretty busy when I came back. So I went back to the same laboratory that I was in before, and we were trying to get Skylab up into a higher orbit. You know, Skylab flew 3 missions, and it started decaying in its orbit, and it was actually up there rolling, and it was also going like this, wobbling, and it was also going end over end. We had a simulator at the Marshall Space Flight Center that, if you can just picture yourself in the back of the orbiter of the Space Shuttle, we were going to launch a teleoperator system out of the back and fly it over and dock to Skylab and put it up into a higher orbit. And we practiced that, I did, every day. I could fly the simulator as much as I wanted to. Our Houston astronauts would fly up and get in the simulator, and we would start them from the go with a full load of fuel, and they would fly out, try to dock to Skylab and put it up into a higher orbit. A lot of times they'd run out of fuel, and we'd have to restart that process all over again, and they'd try it again. Now keep in mind, I'd been flying it 5 days a week, 8 hours a day if I wanted to, and had developed some techniques that were really working for me. They went back to Houston and said it was kind of a no-go mission. And our director of engineering told the Senate subcommittee, well, if the folks can't do it down in Houston, we've got an engineer at the Marshall Space Flight Center that could. And unfortunately, we didn't get the shuttle up in time. Believe me, the astronauts would have picked up all the techniques that I had learned. We didn't get it up in time, and unfortunately Skylab decayed in its orbit and crashed into the ocean and into part of Australia. Of course, we have a display over here of an oxygen tank that survived re-entry, paid a $400 fine for littering, and brought it back here to put it on display for all you fine folks. The Skylab Reboost was flying out of the back of the orbiter.
Okay.
So out at TRW, we had developed a teleoperator system. It was just a remote control fueled vehicle powered in flight, and you'd fly it from inside the Space Shuttle over to Skylab and reboost it into a higher orbit. But that was a lot of fun because I found myself going out to Denver, Colorado and flying with a guy named Fred Hayes from Apollo 13. And I've always been one to just go work and get the job done. I wasn't the get my picture taken with the astronauts or get signatures. But everybody asked me if I ever got alone with Fred, ask him how it was on Apollo 13. Well, you know he gets asked that question all the time. And sure enough, when the computers went down out at Martin Marietta, Fred and I were sitting in a room by ourselves, and I looked around and I didn't see anybody, and I looked over at him. I said, "So Fred, how was it on Apollo 13? And he rubbernecked the room to see who put me up to it. And when he sees nobody else is in the room, he says, "Well, other than I almost died," but then he went into the real process of what it took for them to come home. He had a UTI. He had an upper respiratory issue going on. They dropped the temperature in that command module below 40 degrees. Water was dripping off of all the instrumentation as they worked to conserve the battery inside the command module by sharing systems that were inside the limb for their journey back home, and the cleansing of the oxygen that they exhaled to allow them to stay alive, and then everything obviously powered up and brought them back home. But he said it was really through the ingenuity and the engineering skills from all the centers that were involved to bring them back home. You know, it made me better appreciate when you're actually the person flying the airplane, what went into the design of the aircraft. The C-130 was a very forgiving airplane, and it had a lot of redundancy to it that brought me home every day. So that's followed me my whole career. What does it take to maybe do a little something extra to make sure we had either the redundancy or the safety checks or the fail-safe capability in anything that I've worked on, from Skylab days all the way through the Space Shuttle program.
It's all about the testing, isn't it?
It's all about fly what you test and test what you fly. And if you fall short of doing that, unfortunately, you'll find the mistakes during flight. John Young was my favorite astronaut. John was in Gemini, Apollo, and he was our first shuttle commander. When John was 8 years old, there was a knock at his door, and they took his mother away. She had a mental illness. She was a paranoid schizophrenic. John's dad was a delivery man, and he was able to graduate top in his high school, college, flight school, astronaut corps, and fly all those different missions. He was a lot more passionate in college than I ever was. John would study 6 nights a week to 1 o'clock in the morning. And when we were all ready to go home, after briefings and issues that we would raise for a space shuttle flight, and John wanted to work longer, nobody ever argued. We just kept on going. But it was that kind of experience I got working with Von Braun and his team initially back in the late 60s when I came on board, to the people that followed those skill sets, the work skill sets that you need to work in this industry. They followed me my whole career, and I'm trying to pass that along to the engineers that I get to work with today. But it's fun.
Yes.
When you enjoy your passion, it's not work.
Yeah, that's true.
It's really neat. I got out of the laboratories and got into a program called Program Control, and it was looking at cost, schedule, and technical performance and managing contractors that were out doing the work. So I got involved in the front office, if you will, that took all the budgets that were required to go build the space shuttle, the components that we had at the Marshall Space Flight Center, and present those to senior NASA management. And then the opportunity came along to break away from the shuttle for 1 year. I got to go out to the West Coast and work with the Department of Defense, the Air Force, on an advanced launch system, a family of vehicles and rockets that we could share between NASA and the Department of Defense. So I was the Deputy Program Director of the Advanced Launch System. And for 1 year, I'd find myself going with the boss, who was a one-star selectee, to the Pentagon on a Friday afternoon at 5 o'clock in the evening, get up at 7 o'clock and find myself in the Pentagon briefing 3-star and 4-star generals on the program that we were trying to get Congress to approve. And unfortunately, in the 89-90 time frame, Congress wasn't ready to go move out on that family of vehicles that today we're building over in Decatur at the United Launch Alliance. But I still was able to get that experience, and it was a tremendous experience as the Air Force shared with me other programs and projects that they were working on, and I wouldn't give anything for that 1 year time back out in the Los Angeles area working on that program. And then I got a chance to work on the Space Shuttle external tank. I got selected to be the Deputy Project Manager on the fuel tank that actually holds all the elements together, like the orbiter and the solid rocket boosters. It's built down in New Orleans in a 43-acre facility, heated and air conditioned under one roof. And what an opportunity it was to work with a team that really provided the fuel for the Space Shuttle main engines and to take us all the way to orbit. So if you can just imagine, there's over 3,000 people at the Martin Company, later Lockheed Martin, down in New Orleans, that would build an aluminum tank, only 55,000 pounds. It started off at some 70,000 pounds. And through different programs that we had, we were able to reduce the weight of the external tank, which allowed us to put more payload into the Space Shuttle to low Earth orbit. And then we put these large vessels, just like the Saturn V that's in here, on a barge and pull it behind a tug with a 1-inch wire rope, 2,500 feet long, through the Gulf of Mexico, around the Keys, up the Atlantic coast, and offload them and put them up on the 8th floor of the vertical assembly building down at the Kennedy Space Center. But it was really great working with the engineering team out here at the Marshall Space Flight Center as we went from aluminum to aluminum lithium to get the weight of the tank down, to work with all the contractors out there, even on the other elements, in a very collaborative relationship, real teaming effort for all of us to get the job done. It was really rewarding. And it really came together with a Space Shuttle launch. And it was so fun to be able to join my colleagues, men and women, out here getting on an airplane at Redstone Arsenal and land on the shuttle landing strip down in Florida and go through a launch -2 and a launch -1. On the external tank, I typically go to work about 10 hours prior to a launch, and I go into the firing room in the Launch Control Center and take my place at a console, and my team would load 535,000 gallons of fuel, 1.9 million pounds, into a 55,000 pound thermos bottle that we called the external tank. And we bring the crew out about 2.5 hours prior to a shuttle launch. And at about the T-9, we did several polls during the night. We'd eventually give the launch director permission to go fly. And at T0, when the computer now counted down to 0, the engines would light on the Space Shuttle. And the external tank is sitting over here as the highest point on the launch pad. And while it's still bolted to the launch platform, this would move some 3 feet while it's still bolted to the launch tower. And when it sprang straight back up and down, NASA calls that twang, we'd light the solid rocket motors. And we're doing 100 miles an hour before we clear the launch pad, getting up to 17,500 miles an hour, 5 miles a second. And that's just amazing to me. And to know that you're sitting at the console with your team and you've done everything that you know how to do to bring them back home safely was always such a refreshing and just a good feeling, you know, especially when the mission was done and they came home safely. We brought the Space Shuttle back home and got to reuse it over and over, and we got to bring the solid rocket boosters back. The external tank went to orbit and then decayed and came back into around New Zealand and disintegrated for the most part coming back in, but we still cleared a debris field 150 miles wide and 2,500 miles long and keep our mariners back out of it. We wanted to do other things, but our budget really limited what we could do. A lot of us want to have flyback boosters, like what you see today with SpaceX and flying their Falcon back. That's a tremendous capability to be able to reuse that hardware over and over again. So that was some of the things that I missed doing in the shuttle program. Back in the 60s, we had the national support of some 4.5% of the gross national product to go to the moon. And for the most time that I worked at NASA, all of NASA had about 0.5%. The shuttle program was only 1/10 of 1%. So we did not have the resources that we would have liked to have had to really improve that capability. You know, both our Congress and the public had kind of lost a little bit of its support to the program, and we're on to other things that they thought we should be working on.
It's always a challenge to get that budget in line with.
Oh, absolutely, and it's got to start at the top. You know, if it doesn't start from the president and find its way through the Congress down to NASA in this case, it's just not going to last as long as you'd like for it to. Shuttle lasted a long time, and I've got no regrets about it. But we had to really terminate the shuttle program for a lot of reasons. One of them, it just restricted us to stay in a low Earth orbit as opposed to being able to go back to the moon or go to Mars or go to an asteroid. But you know, like I told you earlier, shaving off 20,000 pounds on this external tank through using different metals and don't need as much foam in this area, the paint was 500 pounds.
Oh.
And so when we got the paint off the vehicle, because we really didn't need it, we found out that we could carry 500 more pounds of cargo, 500 more pounds of food. You know, when you think about it, it all starts adding up. So I thought it was kind of neat. I mean, it was latex paint from Sears and Roebuck. So, you know, I mean, it got a NASA number on it, but it was just regular old latex paint. So I was standing on the side of the runway when the last shuttle landed, and this was back in the 2011 timeframe. And by this time, I'd left NASA some 15 years earlier to go out and pick up and be the director, the program director of the external tank in the private sector when we had the Columbia accident. And so my efforts at that point in time was refocus to return to flight, to get the shuttle back flying after Columbia, after we lost Columbia. And that was a joint effort. You know, I reached out to people that I thought could help find the right ways back to safely return us to flight. But it just took some time to make all that happen. But it lasted, like I said, into 2011 timeframe. I was working for a company that had 10,500 people supporting, and it was a joint program between Boeing and Lockheed Martin. And as we saw where the program was going, i.e. phasing out and shutting down, we had several end times that kept getting extended. And so it was really a privilege to keep working with the program to the final shuttle landed. And at that point in time, I thought they were done with me. I just turned the ripe old age of 60. My dad will be 100 in September, so I don't want to retire too soon. Anyhow, I really got a call that made my day. Boeing called me up and said they had some issues with the thermal protection system on the new space launch system, the new rocket that's going to take us back to the moon and on to Mars. And so I came back in for what was going to be a 6-month assignment. That's been 3.5 years ago. I keep finding things where some of that expertise from earlier programs that I worked on helps us go in the right direction to get this vehicle up and get it launched. We were supposed to launch back in 2017, and we probably won't launch this vehicle until 2021. But it's got more power. It's very much like the Saturn V overhead in here, but it's got more power than that. And it's going to be able to do things beyond the moon that we weren't able to do with a Saturn V. You know, the Saturn program was a kerosene, hydrogen, and then hydrogen and oxygen vehicle in the second and third stages. So the shuttle program went totally to hydrogen and oxygen. And I've always worked around cryogenic vessels, fuels. And, you know, what's important about that is you have to have an insulation on it. If you don't have insulation on the tanks, there's a lot of things that can't get accomplished. There's a lot of things that can happen that you don't want to happen. Anywhere that there's bare metal, you're going to grow ice. Growing ice and having ice come off and hit the orbiter made for a bad day. Having foam come off in a large quantity made for a bad day. So working in the thermal protection system, the actual foam that goes on the core stage of the space launch system is what I've been focused on in getting that foam qualified. You know, every so often the EPA will come along, Environmental Protection Agency, and change what we're allowed to use that blows this foam onto the cryogenic tanks. Went through the second generation blowing agent back in the day. And right now we're working on the fourth generation blowing agents. We stopped having blowing agents that damage the ozone. In fact, in the effort that I put together, along with a fantastic team, we reduced the ozone depletion from 100% down to 15%. But when you talk to groups like the EPA or the Montreal Protocol, they want zero. And folks after me got it down to zero, but now we're into global warming, and so now we've got another figure of like 1,475 units that we're supposed to get down to about 1. So we're off on an endeavor now to come up with a new blowing agent for the Space Launch System. It won't affect the first several missions, but it will out beyond 2025. And these are things that you have to be able to see in advance and go get redesigned for, because the vendors will stop making what you've used in the past. Refrigerant like what you have in your car air conditioning or in your refrigerators at home or your air conditioning systems at home are all affected by these same things that were the challenges that we had to go meet. Our environment's completely different than a home environment in the vacuum of space or in the launching of cryogenic fueled vehicles. You know, there's always a different day in the office. I'm going to skip back to the shuttle when you come in one morning and you find out that the tug pulling the external tank up along the Atlantic coast is caught up in a hurricane. Should they have ever got in that environment? No. They left New Orleans with a rudder that was broken, and they got down to the Keys and lost an engine. And as they were coming up the Atlantic coast, 9 o'clock at night, they lost the other engine, and now they're afloat, and they're in 30-foot seas. And it's moving its way towards the Florida coastline around Fort Pierce. And I've got a 34-year-old captain of a 700 or 600-foot vessel that's hauling oil, calling me and wanting to know if they can be of some assistance. And during the night, we started putting light lines and then 4-inch lines between this large ship and the tug that was holding a space shuttle external tank and keeping them from going in and hitting the shoreline. More than likely, the tank could have come out of the barge and been destroyed. And it was just a fantastic, fun 2.5 days of pure terror as you worried about the crew on board the tug. And then we had taken people off of the barge for cost savings, and we had no way to drop an anchor. And so we were really at the mercy of this 700-foot Cherry Valley tanker keeping us out at sea, and their crew that did a wonderful job during the night. Those are the kinds of things that came up during the day or during the week or during the time frame that I worked on the external tank that really showed what it took to bring collectively the right people together to resolve a major issue. We wound up eventually flying that external tank on a later flight. You know, I got to meet some of the pioneers of the Space Shuttle program. I mean, it started off by Wernher von Braun being my center director and being able to go to his retirement dinner and being able to shake his hand and chat with him for a few minutes, and it was like we were the only people in the whole room. That stands out early on in my career. Working with the Apollo astronauts that went to the moon, being able to work with them again later on in my career, never thinking our paths would cross again. The unbelievable opportunity to represent my team our team on the Space Shuttle external tank program. I never thought I'd find myself in the same firing room as Von Braun and his team that launched this vehicle, the Saturn V. And to be able to rely and reach out to so many engineers and managers that helped us achieve the ultimate goal of launching that shuttle and doing it right the first time. So those all kind of stand out. You know, I told you about my time with Fred Hayes. It was short, but I really enjoyed crossing paths with him, and then over the years to watch some of these folks bring their grandchildren back to space camp. Jim Lovell comes in here, and you know, from Apollo 13, it's kind of nice to be able to go up and put your arm up on the shoulder of somebody that was your mentor and just tell them thank you and how much I appreciate what you did for our country. So those kinds of experiences. And then today to be able to work with young engineers that had more tools than I did as I tried to learn how to use a slide rule back in my day, to the handheld calculators and the computers that help verify what we're building and how to qualify it and ensure that we've got a safe vehicle. I did work on the Rover. I did work on Skylab trying to get it up into a higher orbit. And it was so neat to fly on an airplane with Owen Garriott. We were flying on a NASA airplane coming back from the Cape, and just have that information shared with me of somebody that went into space for almost 3 months, and some of the things that they had to deal with on the Skylab is just remarkable. And to lose one of their solar panels and what it took to get inside and safe that living environment in there, you know, it's not all written in a book. Some of it's just been passed on verbally and through podcast and so forth, recording this, digitizing this, you know, to be around for others in years to follow. The opportunity to come back in here as a docent and share my experience with these young folks that come through here, and adults alike, of what opportunities I have. Maybe to turn on a light bulb in one of these kids' heads that inspires them to get into whatever career field they're interested in. It doesn't have to be aerospace. I've had students that have come through the camp, have kept up with me over the years, and have sent me emails, and now they're out of high school and they're in college. And I'm so amazed at how bright our young people are and what kind of impact they're going to have on our society and on our going forward in this world and make it a better place to live. So the legacy I hope to live is maybe demonstrate by my actions of things that I've done, but to share those in such a way as maybe they would like to do something like that too, and to know the sky's not the limit anymore. And if you can dream it, you can do it. And just try to give them that extra little bit of encouragement. And then to talk to people that, like I say, come in here from all over the world and share some of the opportunities that I've had. And they really enjoy coming through the museum and learning about what we did back in the 60s, 70s, 80s, 90s, and now we're into the 21st century and the things that we still have left to do. There's still a lot on our plate to be accomplished, and I just hope I'm around long enough to see some of those things happen. I want to leave it better than I found it. And I tried to do that where I've been, whether it was working at NASA or working for the aerospace companies that I work for. I want to leave it better than I found it. And that's getting harder and harder to do nowadays. Within the limited budgets that we have, which some folks tell you they got everything they need, but they don't. They really need the resources to get the job done right the first time. And so I don't want anybody cutting corners. And so this one sign that I put on my cube when I went to work at Boeing is to test what you fly and fly what you test. And I want to leave that with the folks that are behind me to know how important that is. My mentors left that same thing with me. And the more experience that I've gotten over the years, it has really come to reinforce what they told me so many years ago, that I need to make sure I leave that behind. If you skip steps along the way, you're going to pay for it later. And we can't afford to skip any steps.